going on, everybody? Ben with Buy It, Break It, Fix It. We're here with Colin. He's at my local hobby shop.
How's it going, guys?
Colin and I decided to do a little tutorial, or a little, I guess, tech video.
A little soldering video, a little how-to maybe, and hopefully get some of you guys up to speed, maybe do some soldering yourself. So
just some basic tricks and tips that he's learned over the years. He's been in a hobby for 17 years, and he's been here at the hobby shop for 11. So definitely some good tips that he's going to pass. Any idea what we're going to start with first?
Well, we're going to do the wire tinning, because that's the base for all soldering. If you can't tin a wire, you cannot attach it to any type of connector. So we'll start a little bit with a little bit of wire, tinning it, and showing you the process there. And then I thought we would do two different style connectors, and I think these are the most popular in the hobby. I've got a Traxxas female for battery side, and then I got a Dean's male and female. And I think the car guys predominantly use these. And if you want us to use something else, maybe an EC3, EC5, maybe one of the Castle connectors, you know, we can go around to do those too. But
I know Colin and I talked earlier, and he's like, just act like you don't have any experience with soldering and just ask me questions. Well, guess what? I have no experience with soldering. So tinning, what is tinning?
Tinning is essentially taking the bare wire and introducing solder to that wire. And basically, one of the most common mistakes that I see is people trying to put the bare wire onto the connector and just feed solder onto a bare connector and bare wire. It's not going to work. It's going to have a bad time doing that. So you have to do a three-step process where you tin the wire, and then we tin the connector, and then we melt the two together. And that's the process I've been using for the past 10 years, and it works really, really well.
Everybody getting that? I hope so. All right, we'll get the camera set up over here, and we'll get going. Okay, so this is Colin's setup. This is his workbench here at the hobby store, and he's going to just go over some of his tools and how he kind of goes through it.
Absolutely. This is the Hakko soldering station right here. You can see it's heating up right now. This is a Hakko 888 digital. It holds temperature within a half a degree. That's really important to be able to hold the temperature and the heat energy in your tip. You'll get some of these soldering irons that you'll plug into a wall, and you're wondering why this is just not working for me. The reason for that is it heats up really, really hot, but as soon as you touch it to some solder, as soon as you touch it to some wire, whatever you're working with, it's immediately going to suck all that heat out of that tip, and it just doesn't hold it very well. So this is why, you know, here at the shop, we're always using the station. It's very, very consistent, and just makes soldering that much easier. So tools make the job. This definitely helps us out right here. And again, if you look, we're actually soldering pretty hot here. This is Dave, my other coworker, and my preference to solder at 830 degrees Fahrenheit. And the reason for that is we can get in and out of a solder joint very, very quickly without introducing much heat energy into the wire, into electronics, into batteries, wherever we're soldering. It's going to stay very close to that joint without doing a cold solder joint. So we like right at about 830. For beginning, you can go anywhere from about 750 to 830. So that's the soldering station set up there. Now we got the base that we solder on. All it is, ceramic piece of tile from bathroom or kitchen or wherever. One of our old co-workers donated to us, and it works beautifully. It works really, really well. We can solder on it all day long. It doesn't mind temperature. It's not going to damage anything. It's not going to catch on fire. It's great. And then after that, we've got tooling. And basically, we use pliers with rubber band as a jig. It works really, really well. We've used pre-made jigs in the past, and they just don't seem to hold up very well. So the best solution we found, a pair of pliers, just your regular pliers with a rubber band to hold connectors. Works really well. For Traxxas connectors, we'll show you these here in a bit. This is a pair of C-channels or channel locks, also with a rubber band. And I'll show you how to solder those here in a second. After that, standard pair of wire strippers, nothing fancy there, but you can clip wire, strip wire, and good tool to have on hand. Pair of side cutters, again for clipping wire, always nice to have on hand. And then a flat blade screwdriver, which will come really apparent whenever we do the Traxxas connectors. Other than that, we've got some other tools here. We've got a torch for the heat shrink, and then we've also got two types of flux. We have the liquid flux, We also have paste flux here. Our preference at the shop is the liquid flux, and I'll explain the differences as well when we get into tinning the wire.
Is it just a cleaner, or is it?
So what flux does is essentially allows the solder to flow where the flux is applied, and in the practice I'll show you exactly how the flux is applied. So basically the solder wants to flow to the hottest area, which is generally the tip of the iron. And that's not where we need it to go. We need it to actually go into the wire or onto the connector. And the flux essentially just helps with that. It's you can solder without it, but this makes life a lot easier to solder with it.
Okay. Sounds good. Sounds good. And if you have any questions or comments, Colin would be more than happy to answer them.
I'm always lurking on the Facebook page.
Yeah, we're kind of trying this out. You know, if everybody likes these videos, we might do a Tech Tip Tuesday or something. I don't know. And Colin could turn into a regular on the show. So if you like him, let us know.
Cool.
So he's a good friend of mine. He's not going anywhere. So, okay. Where do you want to start then?
Well, we can start with actually tinning the wire.
All right. So we got the camera all set up over here, and Colin's going to do his magic.
So I thought we'd start off with tinning wire, and basically this is just standard 12 gauge silicone wire, nothing fancy about it. It's what we're all familiar with here. Okay, and when we're getting ready to tin wire, well, we need to strip back some of the sheathing here, and usually you know, I'll strip back close to an 1/8 inch or so. Nothing too fancy, nothing too much. Pull that off right there, and then we have our nice braided wire right there, as we can see. And I'll take this and I'll just basically roll it between my fingers. That way none of the strands are missing, and we can get a nice solid connection with our solder here. So basically that's what we're looking for right there. As soon as we strip it back, we don't want any strands missing, and a nice tight. We'll take our flux, and I'm going to start with liquid flux because that's what we use here most of the time, and we just have a little squeeze bottle right here, and we're just going to put a couple drops. I don't know if you can focus in on that. Couple drops right on the end of the wire there. That's all we need. We don't need to put a whole lot on there. It's just a couple. This is basically a brass cleaner. It is a waterless system. A lot of people are familiar with the little sponge that you soak in water beforehand, but for us here, we're constantly soldering, and for us to be running back and forth to the sink back there to wet the sponge is just not feasible. So this is also from Hakko. It's just a waterless tip cleaning copper mesh, and it works really well. Introduce our solder.
Solder is here.
Okay, the type of solder that we're using here is 6040 rosin core. Okay, so basically that's going to be our most common type of solder. There's silver solder out there, and a few others, and a few other ratios of solder, but the 6040 rosin core seems to be the most common, and it works really well. And the diameter is 0.7. I believe that's 0.7 millimeter. I'm not 100% on that. I'm sorry, 0.03. Very thin.
0.03 rosin core.
Rosin core, 6040 rosin core. Okay.
Okay.
From there, I'm going to have my soldering iron tip just underneath of the wire right there, and I'm going to feed solder in between the tip of the iron and the wire itself. And I'm watching for basically the smoke trail. That's the flux burning off right there, and the wire itself. And I'm watching the solder soak into the wire. And what I want to see is basically I can put the solder on the other side of the wire from the tip and watch it just flow right in. Okay. And basically I'm looking for it to get nice and shiny. Okay. What we're doing also is this is, you know, basically that's tinned right there, but we can hit it one more time, see it turn shiny like that, and let go, and we want it to stay semi-shiny. Okay, and right there we know that the solder has flowed all the way through the strands of wire right there. This is a tinned wire right here. This is good for soldering onto a connector now.
Very nice. Okay. Very nice.
And again, now that I've soldered, you know, and tinned this wire here, the tip itself still has some solder on there, and you can actually, I don't know if the camera's picking that up or not, it's starting to burn and oxidize. And basically, whenever that happens, the flux inside of the solder, the rosin core inside of there, has started to burn off. This solder is no longer good. We actually have to clean the tip now. It's no good for connection if we have our tip like that with solder, old burnt solder.
Well, another thing I just learned, because I didn't know that solder can actually be burned to a state of where it's not good.
It's not necessarily the solder. It's actually the rosin core inside of there that's oxidizing over top of that.
Okay.
So we're going to actually start with the Deans, because I think they're the easiest ones to learn with, and they're also, again, very common in the car side of the hobby here. A lot of car customers still come in and request us solder Deans for them. So basically we're going to open these up real quick. And basically this is just a standard pack of Deans. I have one male and one female. This is the male right here and the female right here. The male side is generally on your device or your charger or your ESC or what have you. You do not want to put that on the battery. The reason for it is these pins right here are exposed at all times when not plugged in. And if we have this hooked up to a battery and something metallic comes across like this, we've just short-circuited the battery and it's going to arc and potentially damage your battery or kill it. So we're always using the female connectors, and we're soldering to these silver tabs right here and putting heat shrink over top, so it's protected. There's going to be no exposed wire, and the inside pins right there are going to keep protected, and you cannot arc across this. It's inside of a shell.
Right.
So we're going to actually solder to the female one here. The process between soldering to the male and the female is exactly the same. Okay. Cool. So we're going to get set up here, and this is kind of where the jig comes into play right here. This is our soldering jig right here, our very fancy, high quality rubber band right here, and basically plier set. So basically, I can put it in there just like that. Okay?
Yeah, he's a pro when he's joking about his jig that takes care of all of our hobby needs.
Yes, absolutely.
It works good for him.
The other thing I forgot to mention, on the back side of the plug, and I'm not sure if the camera is going to pick it up or not, there is a soldering guide. It will actually tell you what is positive and what is negative on here in terms of the pin layout. If you ever forget, you can look there, or on the back side of the connector. It'll also tell us the exact same thing, this guide right here. So basically, I like to look at the flat pin right there, going horizontal, that's our positive, and the vertical pin, that is our negative. Okay. So if we go back to the connector here, this right here is the horizontal pin, that's our positive, and the vertical pin just below it is negative. Now the correct way, or the way that Deans wants you to solder, is actually from the wire on this side right here. I don't like that because it gets too close to the negative pole. There's nothing saying you cannot solder from the top side right here like I'm going to do. Okay, it gives me more room to solder to the negative side down there. Okay. Now I've seen many people also make this mistake. The next thing we have to do is slide heat shrink over the wire, and with this it's not a big deal. I just have a stretch of wire. It's not connected to anything, so we can put it on after the fact. But if we have this attached to the speed controller, battery, what have you, we need to slide the heat shrink over first. Okay. We've already tinned our wire here. We now need to tin the connector. So again, we're going to go back to the Flux right here. It's the same stuff I used on the wire, and again, just a couple of drops right on the tab. That's all we need. Okay. And again, make sure our tip is clean.
So after we're done with this, you can send all of your soldering needs to Ben, but buy or break it now. I'm just kidding.
And again, we're going to actually heat this contact up before we introduce any solder to it, just for a second. And we're going to now put the solder in between the tip of the iron and the connector. And you can actually hear that flux start to burn off and the solder start to flow through the connector. And that's what we're looking for right there. Just a little pool of solder, nice and shiny, nothing too fancy, right on the Deans connector there. Okay.
Looks like he's a pro. Oh, what's nice is you could see that glaze over on the camera. Very nice.
Yep. So basically, we're now ready to solder these two items together, the wire and the connector. We've got them both tinned, and now we can basically combine the two. And again, before I put this wire to the connector here, I'm actually going to put a little solder on the tip of the iron, and that's just going to help melt the two together. Because basically, I'm going to take this wire, I'm going to lay it right on top of that contact right there, and now I'm going to take my soldering iron right on top, and I'm just putting a little bit of pressure, waiting for them to both melt together. And I'm looking at the connector underneath and the wire, and basically they've started to melt together. As soon as they do that, I release the temperature, take the iron off of the contact, and that's it. We are soldered to it.
Beautiful.
Okay? And what we're looking for is just a semi-shiny finish to it. If it's really dull, that's a cold joint. That's not going to hold up very well, but this has a little bit of shininess to it, and that's exactly what we're looking for with 60/40 rosin core.
Okay, well, let's see what I'm learning. And my question will be for you as a newbie. When you, I guess not a question, but more of a statement, but right before you get ready to solder the two together, tin your tip of your gun, you pretty much have how much time until you need to get it down here, because or else the flux will burn off.
Exactly right. So you do have a little bit of time. You know, you can put solder right on there, and basically what you're looking for is the smoke starting to rise off the tip. As soon as the smoke starts to dissipate and go away, that's whenever that rosin, that flux inside of the solder, is starting to dissipate and go away. And you notice that I don't know if the camera's picking that up or not, but the smoke is starting to dissipate more and more and more as it's sitting there, and the color of the solder is actually starting to change from silver to kind of a bronzish color. And that's whenever we know that it's no longer viable to use. We actually have to clean and start over. So we have a good 5 to 6 seconds once we've put some solder onto the tip of the iron to melt our two pieces together here.
Okay.
So we have a little bit of time to work
Okay.
with. A little bit of practice, everybody can do this. It's actually pretty easy, and again, it's getting your setup right. We have the ceramic tile here and our very expensive jig setup, and really nice soldering iron. So.
And honestly, you could probably go to Home Depot and get a broken tile. You're not a hobby shop, I wouldn't assume. So you can do a half a tile. You know, I'm sure they have broken tiles in there all the time. If you go in and talk to somebody, I'm sure you could find one.
And I'm just going to finish this off with a little piece of heat shrink since we have it here. This is nothing fancy. There's a couple of different ways that you can heat shrink. We do have the torch here. If you don't have a torch, you can use a lighter. If you don't have a lighter, you can actually use the soldering iron itself. Okay, and basically, with the soldering iron here, we can use the stem right before the tip, and we can actually just touch it to it, and it's going to start to shrink right around. And we just want to go all the way around this and adjust the heat shrink accordingly as you're shrinking it. So go all the way around.
So you're just using where the tip is less hot, obviously.
I'm not putting it directly on the tip. That's at 830 degrees.
Right.
That would actually burn right through this.
Right.
I'm putting it on the stem, which if I were to guess is probably 300 to 400 degrees, and I'm not leaving it in one place very long. I'm moving it around quite a bit. So like I said, you know, that's heat shrunk on there. That connector is now pretty much done. We don't have to worry, you know, about, you know, anything metallic coming in contact if this were on a battery and direct shorting this out now, because this heat shrink is here. The other thing the heat shrink is on there for, and I just learned this the other day, and it's actually makes sense, is it's actually a stress relief for the solder joint right here. So basically it starts to flex the wire after the heat shrink instead of right at the joint there. Okay, so you know, basically it just gives you some added protection. Okay.
Nice.
And then touching back on another reason why we solder so hot, if we're on here for an extended period of time on the wire specifically with solder, it'll actually start to pull solder up the wire itself. Okay, that's all the more reason to get that wire tinned as quickly as you can without having it just pull on the top of the wire. You want it to flow all the way through, but not up the wire.
Okay, so now we're going to do, well, Colin's going to do the Traxxas connector.
Yeah, so basically this is where the channel locks come in. Have channel locks, you can get around it, you know, using a pair of pliers like these here. It's just a lot easier for us to use the channel locks, and we have the advantage to being able to clamp to our workbench right here, and that's why they're set up at this particular depth, I guess you would say. And you know, this rubber band tension, it's set up perfectly for what we got going on here. But basically this just wraps around our workbench right here just like that, holds right in place. Okay, open up our Traxxas connectors. Now this is the Progressive RC brand of Traxxas connectors. Traxxas themselves actually discontinued selling their TRX style connector in hopes that their ID connector would replace it, and it has, but you cannot get the ID connector separately. So Progressive saw a need in the hobby, release their version of the Traxxas connector for people who like to use them but don't necessarily want Traxxas product. And we thank them for it because it makes our lives here a lot easier to be able to put on a Traxxas connector for a customer that requests it. So basically, we'll set the shell aside for right now, and we're going to start with these contacts. And with the PRC connector, Traxxas version of their connector here, there's two ways you can solder these, okay? And it might be difficult for the camera to pick up, but there's a little semicircle cutout right here, or a circle cutout on the connector itself.
Okay, bear with me. I'm going to try to get that on camera here real quick. Semicircle. Yep.
And it's right at the tip of the connector right there. And that semicircle or circle needs to be basically up when we're soldering into the female connector and down when we're soldering into the male connector. But for purposes of the female connector, we're going to leave it facing up.
Okay. So female connector, it needs to be up like a bowl of cereal.
Yep, there you go.
Okay.
Okay, and basically we're going to put this into our C channels right here. And if you noticed, I clamped the connector just before these little ears pop out right here. We cannot have solder flow past that. That's where I see the most common mistake with Traxxas connectors. If solder flows past that, it will not fit into the shell. It just plain won't. Okay. And if it does flow past it, it's not the end of the world. There are ways to clean that up, and I can demonstrate, how you clean it up as well. So.
Okay. So the two little ears there are basically your stop point. Let you know that's stop, don't go any further.
Yes.
Okay. Okay.
So again, we're going to do the exact same thing that we did with the Dean's connector. We're going to strip back some wire. Okay. Again, with the Traxxas connector, we're going to use a little bit less wire on there because we have to fit it inside the shell here. Okay. We don't want exposed strands sticking out there. Okay. So we need a little less than we did for the Dean's connector there. And again, same process. We're just going to twist it, make sure none of the strands are loose. So it's all nice one piece, just like the one before. Nothing different there.
Okay.
And we're going to tin it, and that starts with flux. Actually, you know what? I'm going to use the paste flux here. Most people are familiar with the paste style flux that we have. We prefer the liquid because it basically, as soon as we hit it with temperature, it starts baking off. And it doesn't leave any residue behind, and it works really, really well. The paste flux, it works well. Basically, we start by dipping the wire in here and twisting it around a little bit. We just need a little bit on there. That's all we need. But sometimes it leaves a little bit of a residue behind that it makes the wire sticky and just a little bit unpleasant. But basically, we can start right there, and now we can actually add some solder back and start tinning this wire. And again, if we take a look at the tip here, it is clean, but it's actually a little bit dull, okay? And basically, it's starting to burn in a little bit. And basically, what we do to clean that up, we'll put a little bit of solder on there, on both sides. And this is only if the tip is clean, but it's starting to look dull and not shiny anymore. Put a little bit of solder. And then we'll actually go and we'll clean it up again. Okay. Now it's gotten some of that shininess back to it, and that's going to conduct the heat a lot more efficiently than it would before. So basically, if this tip starts to look a little bit dull, apply a little bit of solder, clean it up, and we're good to go again.
Okay.
So again, the paste flux, back to the paste flux, it works essentially the same way as the liquid flux. We're going to put a little bit of solder onto the tip right here, tip of the iron, and we're going to apply it right to that paste, and that paste is going to start to melt in. And as soon as it starts to melt in, we can apply more solder to the top side of the wire, and it's just flowing right in there. And you can see right toward the sheathing of the wire, the paste flux is boiling up a little bit, and it's just leaving a little bit of a residue. And it's not bad, but it's also right here on my workbench, and it just gets sticky and kind of nasty, and we don't use it very often unless we run out of the liquid flux. We won't use it. The other problem with the paste flux is there's no way for me to you can't put it onto that connector. It's in this jug. I mean, I guess you could get like a screwdriver or something like that and plop a little bit on there, but it's just so much quicker and easier to use the liquid where, just again, a couple of drops, boom, we're fluxed, we're ready to go for tinning. And again, we're going to clean the tip before we tin.
Seems like it's a lot easier just to go ahead and use the liquid over the paste.
And that's our preference. Some people prefer the paste. I don't understand those people, but hey, whatever floats their boat. And if it works for them, it works for them. So we're going to go ahead and we're going to tin this connector. Tinning the Traxxas connector is a little bit different. Basically, I'll start with the iron, add a 90-degree angle to the connector, and I'll start feeding solder into that angle right there. And then I'll start to rock the iron back and forth. So I get good solder coverage over this whole thing. And I'm feeding more solder in as I'm doing this. And basically, again, we just want to see a nice little puddle of solder on the tip of the Traxxas connector there.
Beautiful.
Okay, it looks almost identical to the Deans.
Yeah.
And that's exactly what we're looking for.
Yeah, when it's up this close, it pretty much looks exactly like the Deans at that point. So
basically, at this point, the process of connecting the wire to the connector here is the exact same process as the Deans. Okay, so we're going to clean our soldering tip. We're going to apply a little bit of solder to the tip again, okay, just to coat it. And then we're going to melt the two pieces together. Again, there's the connector, the wire, and then the iron on top of it. We're making a sandwich here, essentially. And what I'm looking for is just the bottom portion of the connector where the solder is on the bottom connector there to start to melt. And as soon as that starts to melt, I know that the solder has basically flowed from the top to the bottom, all the way through there. And essentially, that's what we're looking for again, just kind of a semi-shiny finish to it. Again, if it's a really dull finish right there where the solder is, that's a cold joint. And it's not going to hold up very well. To fix a cold joint, we would just add a little bit more solder to the tip, press it back on there, and melt it through one more time. But that's, you know, if we had it. So from here, we're going to release it from our channel locks, and we're just going to pop it right into the connector. Now, if you noticed, there is just a hair of solder that flowed past the ears here, and that's okay if we're not too much past it or too high. This will still slide right into our connector here. Now the progressive connectors are really nice. They basically just pop right in, and that's all there is to it. Okay, it's in there. And again, the reason why we don't cut that sheathing back so far is so the sheathing will go inside the connector a little bit and basically protect the wire itself.
Right.
If we did have some exposed sheathing there, it would be simple enough to, basically, the nice thing about the TRX connectors here, they can pop right back apart. Put a little piece of heat shrink over top of it, and then again, we're going to pop this guy right back in here.
Nice.
If we're having a tough time getting that wire to seat all the way, we can take our jig again, our nice little pair of pliers with a rubber band. Awesome tool.
Love them.
Pop them right in there. This is where the flat blade screwdriver comes into its own. And basically, we're going to be really careful about it, but we're going to put it right on the tip of the connector inside the shell and just push a little bit. And basically, you'll feel a little bit of a click whenever it pops down in there. And it's not necessarily always audible. Sometimes you'll hear it, but sometimes you won't. But it's in there.
If anybody has anything, I guess we're kind of finishing up here, but you know, Colin, like I said, he's going to be part of the channel here. So if you have anything you'd like to see, whether it be soldering, I know that him and I have been talking about doing a video for battery, you know, maintenance, charging, maybe even add in there, you know, how to pick a good battery for the application that you're doing. So
yeah.
All right, so we're just finishing up. I just want to thank Colin for showing us a little bit of soldering techniques and tips. And we're definitely going to be doing a battery video. I think I convinced them. It's not very hard, but I convinced them to do a battery video too. We'll probably do that next week. We're considering doing maybe like one tech tip video a week. And like I said, if you have any requests or anything like that, just let us know. And I'm sure he'd be happy to pass on the knowledge, I guess.
Absolutely. And you know, I appreciate you giving me the opportunity to be on your channel and share a little bit of what I know about the hobby, and you know, hopefully get some people not so afraid of soldering. It's, you know, a little bit of practice, and soldering all your stuff, it's not a problem. So.
Yep, definitely have taught me that tonight. So I'm not saying I'm going to start soldering.
It's all right. That's why I'm here.
I have him for that.
Yep.
All right, well, I already asked him if he's going to do his outro. He said he doesn't have one yet, so hopefully we'll give him a couple tech tip videos and he can have his outro.
Possibly.
But for now, Ben, out. Ben was out too soon. We have to remind everybody, be a good person, be good to people, and people will be good to you. Have a good day, morning, night, whatever it may be for you. All right, Ben, out.
Take it easy, guys.